These are the 0.1b notes for pre-calculus. We're going to talk today about word problems. So on the left-hand side, you have some steps that are going to help you solve these problems, some ideas that will get you started with it. So make sure you read the problem, like actually read it. Very tempting to just skip over. Another idea, list what you know, pay attention to the units of measurement. Figure out what you are trying to find. It's not always what you think. If it's appropriate, draw a diagram or picture or write an equation. Let's go ahead and get started with example number 1. During a camping trip in North Bay, Ontario, a couple went 1/3 of the way by boat, 10 miles by foot, and 1/6 of the way by horse. How long was the trip? So we read the problem. List what we know. We know we went 1/3 of the way by boat. We know we went 10 miles by foot. And we know we went 1/6 of the way by horse. Figure out what we're trying to find. It looks like we're trying to find how long the trip was. So the total length of the trip. Draw a diagram or picture. We've kind of already done that here. You've got kind of this is what's happening here. And the total up has to be the entire amount of the trip. And then if it's appropriate, write an equation. So I know that 10 miles is a little bit different compared to 1/3 and 1/6. So if I can figure out how far the 1/3 and the 1/6 are together, maybe that'll help me figure out how much of the trip was done by foot in terms of a fraction. So I'm going to add up my fractions of 1/3 plus 1/6. I'm going to get common denominators of 6, so I'll need to multiply by 2. This is like we did the other day. However, in this case, we are not going to want to cancel out the denominators because we're not solving an equation like x equals. We'll just add these together to get 3/6 and then reduce that down to 1/2. So half the trip was the boat and the horse. So the boat plus the horse was half. That tells me that this, by foot, has to be the other half. And that's nice because I know if 10 miles is half the trip, that means 20 miles must be the entire trip. And there we go. 20 miles for the entire trip. Example number 2. A rectangle, 24 meters long, has the same area as a square with 12 meter sides. What are the dimensions of the rectangle? So the dimensions of the rectangle are what we are trying to find. And I think this one's going to be best if we draw a picture. So I'm going to draw my rectangle and then draw a square. Rectangle I know is 24 meters long. That's part of my answer, but I'm going to try to find this right there. I do have some more information on my square, so I'm going to see if I can get that on there. 12 meter sides. So this is 12 meters. That's 12 meters. All the sides are 12 meters. Then it tells me that the area of the rectangle and the square are the same. So the area I can find on the square because I have both sides, length times width, 144. I don't know the side of this, but I know the area has to be 144 as well. So the length, 24, times what will give me 144? 24 times what will give me 144? That's going to be a division problem. 144 divided by 24 would give me 6. So the dimensions of the rectangle are 24 meters by 6 meters. Example number 3. Wyatt can husk at least 12 dozen ears of corn per hour, and at most 18 dozen ears of corn per hour. So he's kind of got a range. If he's working slowly, he can do 12. If he's working quickly, he can do 18. So anywhere from 12 to 18. Based on that information, what is a possible amount of time in hours that it could take him to do 72 ears of corn? So I think the best way to do this is to figure out like him working slowly, right, at a slow pace, and then compare that to him working at his fast pace. So if he's working slowly, he has 12 ears of corn per hour. And if he has to do 72 total, I'm going to do 72 divided by the 12 per hour. And that'll get me the amount of hours if he works very slowly. 6 hours. So if he only does 12 ears of corn, 12 dozen ears of corn, it'll take him 6 hours. What if he works fast? He can do 18 dozen an hour. We'll divide that to get 4. Now the question says, what is a possible amount of time? So 6 hours, 4 hours, anywhere in between is fine. So you could say 4 to 6 hours. Another way to do it, you could take the average of the two, like 12 plus 18, which is 30. And you could divide that in half to get his average. And then you could do 72 divided by 15. Which should give you 4.8 hours. So anywhere in the region of 4, 5, 6, any of those answers are going to be great. You obviously don't have to do both of these. Just kind of trying to show you different methods. All right, example number 4. On Saturday afternoon, Armand sent M text messages each hour for 5 hours. And Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? So when we see the word each, that usually means multiply. So I've got M each hour for 5 hours. I'm going to multiply those. M times 5, 5M. And then you have P each hour for 4 hours. So again, 4P. And then you want the total number of messages between Armand, which is this guy, and Tyrone, which is that guy. The total would be you adding them together. So letter C. For our last one, in the equations above, B and C represent the price per pound in dollars of beef and chicken. So B for beef, C for chicken. And this is happening X weeks after July 1st. So it's almost like we're keeping track of the cost of beef and chicken. What was the price of beef pound per beef when it was equal to the price per pound of chicken? So I want to know when these two things are equal. So one way to do this is we could set our two equations for beef and chicken equal to each other, right? We want to know when beef equals chicken. So we would take our beef equation and set it equal to our chicken equation. We have to be careful with this method, however, because when we solve this, we get an answer for X, and X is weeks. And they don't want weeks, they want the price of beef. All right. So let's go ahead and solve this equation out. I'm going to subtract 0.25x. And subtract the 1.75. Type that into my calculator real quick. 0.6, 0.15, and divide it out. Oops. And divide that in a calculator to get x equals 4, and that's the number of weeks. So once you find the number of weeks, we need to now find the price of beef. Price of beef is this right here. We need B. So we're going to take our 4, plug it into our x. B equals 2.35 plus 0.25, and plug in the 4. Type that into your calculator. And that'll get you an answer of $3.35 for the price of beef. Another option I wanted to show you is you could make a chart. So this is a lot of math going on here. So let's say you made a chart of beef and chicken and weeks. So week number, price of beef, and the price of chicken. Right? So week 1, you're just going to plug in a 1 into the x in the beef equation. So you're just going to plug in a 1 right there. Let me pull that up on my calculator so you can see how it works. Oh, nope, guess not. So type it into your calculator, 2.35 plus 0.25 times 1. Gets you $2.60. And then you do the same thing for the chicken, plug in a 1. 1.75 plus 0.40 times 1. $2.15. Those are not equal. So at week 1, they're not equal. So I'll go ahead and plug in a 2 this time. So I'm getting $2.85. And for chicken, $2.55. Still not equal. But they are getting close. If I noticed that those numbers were really far away, I would probably abandon that idea and go straight to the equations. $3.10. Again, this time I'm plugging in a 3. $2.95. Still not equal. Let me try 4. Gives me $3.35. And for chicken, also $3.35. So a little bit shorter math, maybe a few more problems. But it's pretty easy to see here that the beef is equal to the chicken at week number 4. So what is the price per pound of beef? There it is, $3.35.